Good morning, students. Once again, I welcome you to my video lectures on signals and systems. And in this class, the next topic is on causality. So, causality is a system property, and in the earlier chapters, we have come across causality, stability. These are all system properties. Now, in this chapter of Z transforms, with Hz in your hand, what is Hz? Hz is transfer function. So from transfer function, you can test causality, whether the system is causal or non-causal. That is possible. And in the earlier chapter, in the second chapter, I think, in the chapter on LTI system, we have come across testing causality of systems using impulse response. You remember? Impulse response, if h of n is equal to 0 for n less than 0, then the system is said to be causal. So hn equal to 0 for n less than 0 means it is not left-sided. It is right-sided sequence. Now, in the Z transform chapter, the interpretation will be in terms of ROC. So we know that for a right-sided signal, ROC is outside the circle of radius equal to the magnitude of the largest pole of Hz. I will give example. For example, you take UN. UN is a right-sided signal. What is its ROC? Its Z transform is Z over Z minus 1 and ROC is mod Z greater than 1. Now this is pole. This is the pole of the signal. So this is 1 and ROC is outside. ROC is outside the circle of radius equal to the magnitude of the largest pole. Here there is one and only pole. Z equal to 1 is a pole and ROC is outside, exterior to this. So this is a right-sided. So in the same manner, you can interpret Hz for causality. So what is the condition for causality? Now you will be given H of Z. It will be in rational form. Rational form means numerator and denominator will be in terms of polynomials. So given Hz, now you find the ROC. Look into the ROC. If ROC is greater than the circle, the radius of the circle is greater than the radius, is greater than the circle of radius equal to the largest value of the poles of H of Z. If ROC is greater than the circle of radius equal to the largest value of the poles of H of Z, then the system is said to be causal. Then it is causal. Otherwise it is not, it is non-causal. So interpretation will be in terms of the ROC. So given H of Z, look into the ROC and you examine whether ROC is greater than the radius of the circle equal to the largest value of the pole, then it is said to be causal. Otherwise non-causal. Anyhow, I will go to work out problem. This is the interpretation. Given H of Z, how to check the causality property. Now next comes what is known as stability property. Now for stability, I am not in a position to give proof because we have not yet taken up DTFT. DTFT means discrete time Fourier transform. So after Z transform, I am going to take up Fourier series. So then from Fourier series, we have to jump into Fourier transforms. So in DTFT, it is something related with DTFT. Now what is stability? Earlier we have checked stability property using impulse response. If summation n equal to minus infinity to plus infinity mod h of n is less than infinity, then it is said to be Bibo stable, bounded input, bounded output stable. Now again, stability is tested in terms of Z transform. If all the poles, I am not giving you proof. The reason is we have not yet taken up DTFT. If all the poles of H of Z are inside circle of unit radius, then the system is said to be stable. The system is said to be stable. If all the poles, now look into the poles. Now, if all the poles lie inside the circle of unit radius, then the system is said to be stable. Otherwise, it is said to be unstable. And student must remember that I am not giving that it is related with DTFT, and as I have not taken up DTFT, I am not in a position to give you proof for this. So just I am making a statement. If all the poles of H of Z are inside the circle of unit radius, then the system is said to be stable. In the next class, I will work out problems on causality, testing causality property as well as stability property using H of Z. Thank you.